Extra credit to David for reminding me to record this. Good job, David. You get 0.00000001 points of extra credit on your next homework assignment. I'm going to round that to the nearest integer, which is 0. All right. Madame. B, yes. All right, so here's what we're going to do. There's just one concept we kind of need to talk about for you guys to be successful on today's homework. It's not terribly difficult, but it is a vocabulary piece. And so what we're going to be talking about is we're going to talk about the ideas of congruence.
This looks like a movie.
Congruence versus similarity. Okay, congruence versus similarity. Anyone want to take a stab at what you think this might be?
Something complicated.
Something complicated. You're wrong. It's actually quite simple. Let's talk about congruence real fast. So when we're talking about congruence, we're talking about the idea that there are two images that are the same size and shape. Okay, images the same size, this is important, and shape, okay? Size and shape. So if I'm going to pick some sort of image, okay, I'm going to pick a skull. Okay, here's my skull. Okay, it looks something like that. Hey, that's all I got, all right? Talk to Amy if you want to get the skull perfect, all right?
Amy.
She's busy. She's teaching a class right now. Okay, so here is a skull. Now, if I were to draw a and just be kind and assume that I am drawing this exactly the same. You don't have to point out my minor flaws, David. If I were to draw a skull that was exactly the same. Oh my gosh, I just told you not to do that. All right, imagine my hands are better than they are and I was able to do this perfectly. I think we can imagine this. We would say, stop it. We would say that these were congruent, okay? Same size, mostly, same shape, we would say that these were congruent. We would say they were congruent even if we rotated one of them. Even if I instead drew it like this. Okay? Oh my gosh. It is too big. You're right. That one was pretty bad. I admit it. But we would say even if we rotated it, okay, even if it's not facing the same direction, we would still say that it was congruent. All right? Does that make sense? It's a pretty fancy way of saying something that's pretty simple to understand, right? That's congruent. It's doing what we expect it to do in the same size and shape. All right. Now, similarity is a little bit different. Okay? Similar items will be, what should I draw now? All right. I probably won't mess this up. All right. A triangle would be similar to another triangle if it has the same shape. But what do you think is going to be different? Yeah, but different size. So if I did this exact same thing, but it was like little. Something like that. We would say, assuming my angles were right and all of that, we would say that these would be similar. These would be similar triangles. Okay? Does that make sense? That kind of makes sense. And we're going to be talking about similar triangles a lot. And we're going to be talking about how we know triangles are similar. All right? Because, and I'll just kind of give you guys a quick little preview of that. When we're talking about triangles, we're talking about angles. So one way, if I had similar triangles, that I would communicate that angles are the same, is I would use the same line to represent that that angle is the same as that angle. Okay, I'm saying that these are similar angles. This one's slightly bigger, but that line tells you that the measurement is the same. Okay, these two angles are going to be the same too, but I'm going to use two lines to say that they're the same. Why do you think I'm using two lines? Yeah.
Because they're not the same as the top angle.
Exactly. They're not the same as this one, but they're the same as each other. So I'm using two lines to show that. And then finally, you betcha, three lines. So those lines are showing similarity. They are showing that they are of a kind. They are of equal measurement. Easy enough? Likewise, if I had a triangle if I had a congruent triangle, not just a similar one, a congruent one, so I'm going to draw it just a little bit bigger so that it matches. Okay? And I were to draw a line like this, and a line right here, that means that those lengths are the same. Now, if I were to do a double line, I would be saying that those lengths are the same, and if I were to do a triple line, I'd be saying those are the same. What we're going to be doing this week is we're going to be asking ourselves some questions. How much information is enough for us to know that these triangles are congruent? How much information do we have to have? What is the minimum amount of information we have to have? You know, if I have three angles and three sides saying that they're the same, is that going to be sufficient for me to know? You betcha. It's telling me every element is exactly the same. All the angles are the same. All the lengths are the same. Therefore, it must be. It must be. But if I didn't have all that information, okay, if I didn't have some of this information, if instead, you know, I only had one angle, one side, would that be enough information for me to know that these were the same? In this case, it's not enough information. But we'll get to that as we push through the week. But I want you guys to be thinking about that. How do we know for sure? How can we prove it? And that's what we're going to be working on. When you guys are looking at the homework for today, when we are looking at the homework for today, it's going to be asking us a couple of things. The first section is just going to be a review of what we just went over. What is congruence? What is similarity? Etc., etc. Just going to have you do a little brain dump on that. This is going to ask you about some symmetry. It's going to have you think about some of the lines of symmetry and some of the diagonals that we've done up to this point. This is, again, kind of review. Just come up with a shape where this is true for. And then when we're doing these ones here, we're going to be looking for the slope between points and using the Pythagorean theorem to understand them, to understand the distance between them. Okay? Any questions on these? Yeah? Is it in your notes? Possibly. Got it. All right. But that should be it. You guys should be able to knock this out probably by the time we're done today. So if you need help, call me over, talk to each other. Otherwise, you guys are free to work on your stuff.